So here we are looking at parallel and perpendicular lines. And hopefully prior to looking at this we did that small assignment which was just looking at observations about parallel and perpendicular lines. So let's look at the parallel ones. What do we notice about the slope? The slope is the same. It'd have to be the same, otherwise they would not be parallel. And what do we notice about the, let's just make sure that shows up a bit more, good. What do we notice about the y-intercept of parallel lines? They're not the same, are they? They're different. Do they have to be different, or could they be the same? If they were the same, wouldn't we have the same line? Because if the slope is the same, if I gave this top line the same y-intercept as the bottom line and put it there, it is now the identical line. So they're not parallel, they'd be the same. So for parallel lines, they have to have different y-intercepts, okay? So they must be different. Good. Slope the same, y-intercept different. Now let's look at the perpendicular lines. On the sheet that you did before, you were able to actually calculate the slopes. And hopefully you came up with the fact that when we're looking at the slopes of these, they look, maybe the first instinct would be say they're opposite, something like that. Well, they do always have opposite signs. One will always be, unless we have a vertical and horizontal, one will always be a positive slope and one will always be a negative slope. So opposite is a good start. They will have opposite signs. But what else was it that they had, the relationship? They were reciprocals of each other. They were opposite signs and they were also reciprocals. This means, as a matter of interest, that their product, if you multiply the two slopes together, their product is always going to be -1. A pair of examples would be, one had a slope of 2, the other one is -1/2. Opposite signs, one is the reciprocal of the other. And if you multiply 2 with -1/2, you will get -1. Another example, maybe we had a slope of 3/4. Opposite of that would be negative. Reciprocal of that would be 4/3. And if I multiply those together, I will get -1. So, perpendicular lines, like here, the slopes are opposite reciprocals. The product will equal -1. What about the y-intercept? Is there anything we need to be careful of about the y-intercept? Here they're different. If they were the same, it just means that the right angle was actually on the y-axis, but they can still be perpendicular. So for perpendicular lines, there's nothing we need to worry about the y-intercept. NA, we could write, not applicable. Parallel, slope the same, y-intercept different. Perpendicular, slope opposite reciprocal, y-intercept, who cares? Good. Because we are going to, we've got a little summary of that chart here. We are going to identify parallel and perpendicular lines. If somebody gives you two equations and says, are they parallel, are they perpendicular, or are they neither, then we need to know what to look for. So my one and only step is put in slope-intercept form and compare. We want to put them in slope-intercept form, I'll tell you in a minute, when we don't have them in slope-intercept form. Here they already are. So the question is, are they parallel, perpendicular, or neither? So what are we going to look for first? Slope was a big thing. Slope, slope. The same, could be parallel. Y-intercept, different, different. Definitely parallel. So these are parallel lines. Okay? Number 2, it's in slope-intercept form. Let's look at the slope first. 4, -1/4. One is the opposite reciprocal of the other. I don't care about the y-intercept, so these are definitely perpendicular. Number 3, oh look, they're not in the same form. This I know has a slope of 5. And this, I would be tempted to say this had a slope of 5. But I know better, because I've made that mistake before. Because this is not in slope-intercept form yet. This is in standard form. And if I were to rearrange this second one, I would get y is equal to -5x plus 6. And lo and behold, we do not have the same slope. One is +5, one is -5, and we might not have spotted that without doing the rearranging. And that's not really good for parallel or perpendicular, so this is neither. They are just two random lines hanging out on the graph. They are not parallel or perpendicular. Number 4, nothing's in slope-intercept form. Let's put it in slope-intercept form. Here, I'm going to subtract x from both sides, and then I'm going to change everything's sign. So let me do that first. So negative y is equal to negative x plus 1. Then I'm going to go through and change all the signs. So get rid of that one, get rid of that one, and change that to subtraction. Then I'm going to rearrange this one. It's a lot easier. Just subtract x from both sides. Y equals a negative x plus 1. Let's look at the slopes. 1 is the invisible 1. 1 is the invisible negative 1. They are opposite reciprocals. If I multiply them together, I get negative 1. So that's a check. So they're opposite reciprocals. So that means these two lines are perpendicular. Perpendicular. Okay? This one, oh, look at this. We've got a point-slope form and we've got a slope-intercept. Well, I could be tempted to say, I know where to find the slopes on both of those forms, and that's great. Slope of 7 and a slope of 7. So far, so good. But can you be sure that they don't have the y-intercept, or can you be sure they have different y-intercepts? Unless we rearrange this little fella, we won't know. So let's take this one down here, and I'm going to distribute the 7 first. So we'll have y minus 3 equals 7x minus 14. And then I'm going to add 3 to both sides. I'm not even going to bother doing it because I know that it's not going to equal 1. So I have the same slope and I have different y-intercepts. So I'm good with parallel. And the last one, whoa, we've got a standard form and we've got a point slope form. So we've got to do a lot of rearranging. We'll do this little fella first. I'm going to add 5x to both sides and get that y is equal to 5x minus 8. I'm then going to distribute this, and I'm just going to put that down there. And then I'm going to add 2 to both sides, and I'll write it down here. Y equals, so I've got the 5x. Take away 10, add 2. Oh, take away 8. Well, look at that. We had the same slope, and you could be tempted to think we had parallel lines, but we have the identical y-intercept. So these two equations actually represent the same line. So they're not parallel, they are the same line. So do be careful when you've got equations given to you in different forms, rearrange them into slope-intercept form, because otherwise you might not be sure about the y-intercept. The slope's fairly easy to look at, but the y-intercept could trip you up. And on this slide, we're going to look at how do we write equations of parallel and perpendicular lines. So let's say you're given information about something and you need to construct the equation. What kind of things might we have? Let's read the question first, and then we'll look to see what the steps are. Write the equation of a line that passes through the point 2, 3 and is parallel to y equals 7x minus 4. So we need to look for two things. Parallel tells you, oh, same slope, same slope. Determine the slope required. So because it's parallel, I know I have to have a slope of 7. And then it says I want it to pass through 2, 3. So I now know that I have a slope of 7 and I've got a point of 2, 3. What form does that remind you of? Point slope form. So I'm going to plug it into point slope form. Oh, look. There it is, plug it into point slope form, and then we're going to turn it into slope intercept. So we will do y minus 3 is equal to 7 times the quantity of x minus 2. We will distribute, and then we'll add 3 to both sides. Y is equal to 7x minus, I'm struggling here, 11. Add 3 to both sides, yeah. So we're good. That is a line that is parallel to this one, but also passes through 2, 3. This one is a line that passes through 1, 3 and is in perpendicular to this equation. So perpendicular, so we've got opposite reciprocal slopes. Opposite is 1/2, reciprocal is 2. So I know my slope is 2, and I want to go through the point 1, 3. And then we just do the same thing, plug it into point slope form. Y minus 3 is equal to 2 multiplied with the quantity of x minus 1. I'll distribute that, and then I will add 3 to both sides. and get that y is equal to 2x plus 1. So this is a line perpendicular to this one, and it goes through that point. And on the last slide, we have some nice geometry applications. Because in geometry, you'll know a lot of shapes have perpendicular sides, a lot of shapes have parallel sides, a lot of shapes have perpendicular sides. We've got a parallelogram, ABCD, we've got its coordinates, and it says, please show that ABCD is a parallelogram. Well, a critical thing that you have to know is that a parallelogram has two pairs of parallel sides. So the question I've put, kind of summarising to myself, is segment BC parallel to segment AD, and is segment AB parallel to segment CD? Because if we can prove that, we've proved two pairs of parallel sides, and therefore we've proved a parallelogram. So, parallel means same slope. So I just got to find the slope between those 2 points, slope between those two and compare, and then the other pair. Remember slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 5 minus, put it in between. 5 minus 1 is 4, 6 minus 1 is 5. That has a slope of 4/5. This one, 5 minus 1 is 4, negative 1 minus 6 is negative 1 plus 6, negative 1 minus negative 6 is negative 1 plus 6, and that is 5. So that pair is parallel. Checking up here, we have got 5 minus 5 is 0 over, I don't care as long as it's not 0, because I know that that equals 0. 0 divided by anything is 0. Unless we've got 0 on the bottom, but we don't because the x's aren't the same. And 1 minus 1 is 0 over 1 minus negative 6 is 6. But who cares? 0. I have two pairs of parallel lines. And the last one, segment AB falls on the line y equals 2x plus 4. So this line is y equals 2x plus 4. And C is at the point negative 2, 1. Okay? Often it's nice to label your sketches. What line does segment BC fall on? So this is the one we want. So you need to look to see, so what information have I been given that I might not have been given directly? I have to find it. Notice our right angle. This line is perpendicular to this one. So the slope is opposite reciprocal. Opposite of 2 is negative 2, reciprocal of that is negative 1/2. So I know my slope is negative 1/2, and I've got to go through this point here. I don't need to know B, I only need to know one point, through negative 2, 1. So we'll put it in point slope form first. Y minus 1 is equal to negative 1/2 multiplied with the quantity x plus 2. Notice it's x because it was taking away a negative. We'll distribute first, and then I'm going to add 1 to both sides. Y is equal to negative 1/2 x. Oh, so 1 disappears. So y equals negative 1/2 x. We have found the line that segment BC falls on. So some really nice geometry applications when you're doing parallel and perpendicular lines. It really suits that. And there we have it, everything on parallel and perpendicular lines.